So here we are at Spot Farm 2 months after planting, and we're about 5 weeks after emergence. The canopy cover you can see behind here, somewhere between 50 and 60%. We're here just after the period when the irrigator has left the field. It's now in another field behind us. You can see it working. And we've timed our first irrigation based on a model system of matching supply and demand. Now, supply is relatively easy to calculate. It's based on the evaporative demand calculated from meteorological data, from the weather station that you can see in the background, and the size of the canopy. But people tend to forget it's not a fixed system. The bucket size varies from very small plants with very small roots up to a much bigger bucket when the canopy has reached full cover, somewhere in the region of 2 to 3 months after planting. Where we are currently is applying our first irrigation, somewhere in the region of a 30 ml size bucket. By the time we get another month further on, we'll have reached about 45 millimetres of available water in the bucket. So clearly the dynamics are changing. Now, people can argue, well, is a modelling or an estimation approach correct? In this field behind us, we've got a series of probes that are measuring down to 50 centimetres into the soil. And the idea is to utilise those alongside the modelling approach to give us a better improvement in our efficiency of irrigation scheduling. So really, it's about the dynamics of irrigation scheduling, matching supply with demand. That way, we will improve the irrigation efficiency and hopefully give us the potential yield that the crop is capable of using from the environment that it's growing in. So we've had basically a split strip in the field where we've actually applied full scheduled irrigation according to the NIAB CUF irrigation scheduling model. And then we've had a strip at the end of the field where we've purposely left the boom not to irrigate. So we've applied 105 millimetres of water to the fully irrigated strip, and on the restricted area we've actually only applied one irrigation at the beginning of August, totalling 30 mils of water. And not surprisingly, when you have that bigger differential in what has ostensibly been a reasonably dry season, the differences between the fully scheduled, i.e. unrestricted, and the restricted irrigation are about 9 to 10 tonnes per hectare. That's what we would expect under such a scenario. But the way we achieve that is quite interesting. As we developed, we got through to the end of June where the first irrigation was required. We skipped an irrigation then, another one about 7 days later, and then we got into the middle of July when it had been particularly hot at the end of June. The canopies on the restricted treatment were beginning to decline. By that stage, we were getting almost into August. We actually applied water at that stage, and as you can see from the canopy covers, we've actually got a significant decline in canopy immediately after we applied the irrigation. So in other words, we've reached the point of no return. We've exceeded the limiting SMD, which is around about 46 millimetres for this site. And at that point, the crop was never going to recover. Not surprisingly, we've lost water use, and the potential of the environment was only satisfied by about 83% to the amount of water we applied as irrigation. The fully irrigated, i.e. scheduled treatment, managed to match about 97% of the potential given the canopy that it actually had. Those systems are inherently there to check whether we've been actually applying the irrigation system effectively or not. The probes have actually allowed us to check out whether certain scenarios are happening. So the probes have been good in doing that. We've shown the variability in irrigation because we've got 3 measurement points. What we also have got is probes that go below ground measuring water uptake. And during that period of mid-July to the beginning of August, the probes were showing we had virtually no water uptake in the 10, 20, 30 and 40 centimetre horizons. So in summary, we've applied 105 millimetres of water to the fully irrigated crop, and that would satisfy about 97% of the crop's potential water use. The restricted treatment, however, because of its poor canopy growth rate and its advanced senescence, actually only met 83% of its water requirements through us restricting water, and that's given us the yield difference.